Hello students, in the previous two lectures we have evaluated indeterminate forms of the type 0 by 0, infinity upon infinity, infinity minus infinity and 0 into infinity. Four types of how to evaluate the limit of four types of indeterminate forms we have discussed in the previous two lectures. Now in this lecture we will discuss how to evaluate the limit of the indeterminate form of the type 0 is equal to 0, 1 is equal to infinity, and infinity is equal to 0. This type of situation will happen if we are given the function in exponent form and we are evaluating the limit of the function in the neighborhood of certain points. When you're discussing limit means we are discussing the limit in the limiting neighborhood point, whether it is whether the limiting value is a finite number or an infinite numbers. Now in this case, when this these type of indeterminate form will come into existence when the variable is in exponent, which is in the powers. So means the function will be of this type: limit x to a of fx raised power gx type of functions. These three type of indeterminate form will come into existence. So we want to eliminate this form, and our aim is to find the finite value for such limiting functions. So let me discuss one by one the three forms. If limit of the fx is 0 and limit of gx is also 0, the product limit of this is equal to limit of this into limit of this. We can go to exponent also. So limit of this is equal to 0, limit of this is 0. When you substitute x of fx by a, this is in 0, and x by a is 0. 0 is for 0. This is first indeterminate form. If limit x to a of fx is 1 and x approaches to a, gx is equal to infinity, then 1 is for infinity. Similarly, if x approaches to a of fx is equal to infinity and limit x to f gx is 0, so this becomes the form infinity to 0. So all these three kinds of indeterminate forms will be evaluated with the same procedure. We have the same procedure to evaluate these type of indeterminate forms. The procedure for this is, let us suppose we want our aim is to find the limit of this. Let this is equal to y. Suppose the function is equal to y. First step is f of x is for gx is equal to y. First step it is. Now same for all three indeterminate forms. Now taking log on both sides. Log of y is equal to log of fx is equal to gx. Log of gx. Here we can use the formula. Log of m raised to power n. So n log of m. So this is equal to, and if you take the limit of both sides, so limit x is to a of x to a of log of x. What is the limit here? X equals to 0. So taking limit of both sides, limit x is to a of, so same in the problem. Whatever I am doing in this article, you have to follow the same procedure for in solving the problems. If product and quotient are there. In case of sum or difference, you have to follow some other procedure. You have solved such kind of problem in the plus two class also. So taking the limit of both sides, limit x is to a of log of y is equal to limit x is to a of log of x gx into log of x. Now if the limit of this is equal to, now if we substitute the limit of product limits, so in the right hand side, if you replace x by a in the both the product functions, so we'll get the form 0 into infinity. This is the form 0 into infinity type of forms. At every step we'll get this type of form, infinity into infinity or 0 into infinity, right? So this form m and x approaches to. So when this form is reduced, we will convert this. We have solved this form in the previous lecture. 0 to infinity or infinity to 0 with 0 on the same type of problem. 0 infinity or infinity to 0. So we'll convert that into either 0 by 0 form or infinity upon infinity form to apply hospital rule. We'll take the right hand side only, on the right hand side. So after evaluating the limit of right hand side, suppose we have the limit x is to a of gx into log of x is equal to limit comes out to be L. How will you find it? We have calculated this with the help of applying L hospital rule. This is a finite number, time and again. We find the limit of the right hand side function and let its value is equal to L. Then we substitute the value of this in here. Substitute the value of limit here, L will be here. So we got this. This is 2a of log of y is equal to L. If this is equal to L, now limit can be taken inside. Limit x is to a of log of x is equal to log of limit x is to a of y. Right? Now we'll convert into exponent form. So this will be, if you become log of limit x is to a of the base e is equal to L, implies limit x is to a of y is equal to e for L. Then limit, let's substitute the y here. Y, what was y? Y is equal to fx is power gx. So this comes out to be limit x is to a of fx of gx is equal to e is for L. Right? Notice all these indeterminate forms 0, 0, 1, 2, and 15 0 can be calculated by the same procedure. You have to remember the procedure and apply it that. Now next is, now let's solve problems. Now we'll compare with the same procedure. This fx equal gx. Limit x is to 0 from positive, fx of gx. What is this form? Limit x to 0, 0 is for 0. So what is one? You have to decide first which form it is. The procedure for this same. So let's put this equal to y. Put fx equal gx equal to y. Taking log on both sides, similar procedure. Log of y is equal to use x, log of x for x log of x. Now we want to evaluate the limit of this. So in log, after second step, third, taking log of both sides as x goes to 0, both sides. Now left hand side will be kept as it is, and right hand side limit of this will be solved by this will become 0 to infinity form. So will be converted into 0 0 form or infinity or infinity form. Then we can apply. If it is converted into 0 into infinity or infinity 0 form converted into infinity or 0 0 form, then we can apply. Now we can apply L to solve limit. Log function there, you have to keep log function in numerator always. So by a rule, index is 0 positive, ddx of log x 1 upon x, ddx of 0 to 1 upon x is equal to minus 1 upon x square. Now again simplified. A upon b upon c upon d is equal to minus x. Limit x is 0 from positive is equal to the following function positive. Now this is L. Now this is L. Put the value of L here. Put the value L here. This is the limit. Put the value this here. Yes, we have calculated the value this limit. So this is equal to, this limit is equal to L. Therefore, limit x is to 0 positive, y log of y equal to 0. Now to be able to convert it to exponent, log can limit can be inside log of x is to 0 for positive, y the base is equal to 0. Therefore, exponent form limit x is to 0 from positive of y equal to, this was 0 is equal to 1. So now substitute the value of y. What was y? X equal to x. Limit x is x. Limit x is 0 from positive, x equal to 1. Now same procedure for that other problem also. Limit x is 0 of sin x upon x is for 1 upon x. Now if x is 0, this is 1. If x is 0, this is 1 infinity. 1 is for infinity form. This had form. This is form is clear. So we have to again take y is equal to, let y is equal to sin x upon x is for 1 upon x. Taking log on both sides, same procedure. Taking log on both sides. Log of both sides is equal to this, equal to log of y is equal to 1 upon n x log of m is to n and log of m. Now this log of m. Now taking limit on both, limit of x to 0 on both sides. X to 0 of this is equal to limit x to 0 of 1 upon x log of sin x upon x. Now we evaluate this limit. First we'll check which form it is. This is 0, infinity, or limit x to 0, log of 1 is 0. This is equal to infinity 0 or 0. You convert it into 0 by 0 or infinity, whatever is convenient. Because you can't take log of infinity, so you have to convert it into 0, 0 form or infinity, conveniently. You can't convert to both forms. So this is equal to, we take this to the denominator. You check this upon 1. At the when you're converting into 0 by 1, you reverse, you check this step reverse. You're getting, are you getting the same thing? Upon 1 is 1, is right, 1 thing. Now name x is 0 of this is equal to 1 minus 0. Limit can be taken inside. Log of limit x is to 0 of sin x upon x 1. Log of 1 is equal to 0 upon x 0. 0 by 0 form. Now you can apply, 0 form is there, you can apply L hospital rule. By L hospital rule, this is equal to limit x is 0 of differential of numerator 1 upon x, 1 upon sin x upon x, dx of sin x upon x upon dx of x 1. Now this quotient, we apply quotient here. So reverse order, x upon, this will become for 1 upon sin upon, or you can take x upon. You have to keep it in the same order. Limit of product of the limits. Limit x is 0 of sin x upon x, 1 upon this, into limit of this. Limit of whole square, denominator, differential numerator, dx of sin x cos x minus numerator x 0. This is this. Now this 1, we are left with this term. Now again put x 0, 0 into 1, 0, 0 minus 0, 0 by 0 form. Again, we can apply limit form here. We can apply L hospital rule. So limit x is 0. This is equal to dx of product is here. First function dx cos x minus sin x, minus x sin x, cos x into dx x 1. Dx of sin x is cos x minus sin here upon dx of x 0 2x. Now again, right, cancel out 0, 0 0 form. 0 0 form, or you can cancel x factor common. You can cancel out x from numerator denominator. This is equal to limit x is 0 of sin x by 2 is equal to 0. Now again L is equal to 0. Now put the value of L. We are calculating this limit. Value this is equal to how much? This comes out to be 0. Now start from next step. Now take the limit inside. Let's go to log limit x is to 0 of y, the base is equal to 0. Convert into exponent form. Therefore, is equal to limit x is to 0 of y is equal to 0 is equal to 1. In the limit. Now substitute value y. 0 of sin x upon x is 1 x equal to 1. Again, next problem. Evaluate the limit x is 0 of tangent of pi by 4 plus x whole raised power 1 by x. You will discriminate. Now 0, pi 4, 1, 1 is for infinity. Now again, to know which type of this form is, you have to solve it by taking out x, the variables in exponents. Same procedure, that y is equal to this function y. Taking log on both sides. Apply formula m log of m is to n log m. Then taking the limit of both sides, limit, taking limit. Then now check the right hand side. Which form is this? Which form is this? This is equal to log of 1, log of 1 0, 0 by 0 form. You can apply that left hand side remain the same. So this is equal to 1 upon dx of log x is 1 upon x, dx of tangent of 5 by 2 minus 5 by 4 plus x is equal to secant square 5 by 4 plus x. Dx of x is 1, or dx of 1 is 1. Now change it to sine and cos. Cancel out the common factor if it's there. Cancel out after cancel out, you will get in the denominator is equal to, in the numerator we will get, where from we get this value 2. Where from this? So we multiply, we got 1 upon 1 upon 2 sin x, sin pi by 4 plus x, cos pi by 4 plus x. We want to convert it into 2 sin x. So multiply 2 divided by 2. Now taking the limit x is 0, 1 upon. So 2 into 1 upon this limit of sin of pi by 2 plus x. X is 0. Pi by 2 is equal to 1. Equal to 2 into 1 upon 1 is equal to 2. Now L is this. Again go to the step. L is 2. Take the limit inside. Limit log of limit x to y plus 0 of y plus 0 of log of e is equal to 2. The exponent form is limit x to 0 of y is equal to substitute value of e y. Now again same question. Next question. Evaluate the limit x to infinity of 1 plus x is 1 upon x. X infinity. Infinity plus 1 infinity. Infinity is 1 upon infinity 0. 0. Exponent and variable in exponent. Again same process. That process y is equal to 1 x plus x. Taking log on both sides. Same formula. M log n. Taking limit same limit x to infinity. Both sides. Limit of this is equal to limit x to infinity. Log of y is equal to limit x to infinity of log of 1 plus x upon x. Infinity. Infinity log of infinity upon infinity form. So we can apply Aristotle rule here. Left hand side limit can be taken inside. Limit x log of limit x infinity of y to the base e is equal to limit x to infinity of 1 upon x. Differential this change L by Aristotle rule. 1 upon x plus 1 dx of 1 plus x is equal to 1 upon dx of x is 1. Now taking limit infinity. The limit infinity this is equal to 1 upon infinity. 1 infinity is equal to 0. Now the log of limit x to infinity of y to the base e is equal to 0. Therefore, limit x to 0 of y is equal to 0 is equal to 1. Substitute the value of y here, same procedure. Now, evaluate the limit. Limit x is to 1 of x equal to 1 upon x. Check whether which form is this. 1 is for infinity, exponent, variable in exponent. Same procedure, y is equal to x is for 1 upon 1 plus x plus x minus 1. Taking log on both sides. The two sides using the formula m log of m is to n log m. Now log of y, now taking limit x which is to x is to 1, both sides. So limit x is to 1 of log of y is equal to limit x is to 1 of log of x upon x minus 1. X is 1 is equal to 0. Log of 1, 0, 0 by 0 form. You can apply L to the right hand side. Left hand side will be kept as it is. So limit x is to log can take inside limit x log of limit x is to 1 of y to the base is equal to limit x is to 1 of 1 upon dx so log is 1 upon x or dx 1 x minus 1 is equal to 1 1 upon x limit x is to 1 is equal to 1. So now convert into exponent form. So log of y plus 1 to the log of y log of limit x which is 1 of y to the base is equal to 1. Therefore limit x is to 1 x approaches to 1 of y is equal to e. Put the value of y here. Where will the limit x is to pi over 4 tangent x is for tangent to x and x is equal to pi over 4. Put the value, check which type of limit interval form is this. Pi over 4 1 is equal to pi over 2 infinity 1 to infinity again same exponent we independent variable exponent. Okay, put y is equal to this. Taking log on both sides. Taking the limit of both sides. Limit will be taken inside. Right inside, check whether it's which form is this. Pi over 4, log of pi over 1, log of 1, log of 1 is equal to 0, log of part of this is equal to 0, 0, 0 form. We can apply the right L host to right inside, left inside, limit log in limit can take inside the log. And after differentiate using action right inside, log of tangent versus 1 upon 9 dx of tan x is equal to secant square x. Convert into sine and cos right hand side and simplify it and evaluate the limit of this. Limit comes out to minus 1, and it comes to minus 1, convert into exponential form. Exponential form and and substitute value of y. Same procedure. Evaluate the limit x is to 0 of a square x plus a square b x upon 2 raised to 1 upon x. Now put x equal to 0, 2 by 2 raised to 1 upon 0, infinity, 1 to infinity. Again, y is equal to same process, y is equal to this, y is equal to function. Taking log on both sides. Log of this is equal to log of y is equal to 1 upon x, m is equal to same formula. Log of m by n is equal to log of m minus log of n. Taking limit of both sides, x to infinity, limit of both sides. Now convert this into, which form it is? Convert this into this is equal to this form, log of and then due to this is x, log of a square x minus plus b square x minus log of 2 upon x. Now put x to 0, 0, 1, 0, 1 plus 1, 2, log 2 minus 2, 0 by 0 form. Now you can try look at right hand side. Therefore, right by on the left side we can take the limit log to the inside, the log is equal to limit x to 0 of dx of log of a is x plus b is 1 upon x plus bx into dx of x is equal to dx of is x plus b is x is equal to a by x log of a plus b is x log of b, and log of constant is equal to 0, and dx of x is equal to 1. Now uh, x denominator is denominator, and we got this equal to, and put x equal to 0. On the right hand side is equal to is equal to 0, which was 0, is equal to 0, log of it, log of b. So is equal to 0 is equal to 1, and equal to 0, 1, 1, but 1, 2 is equal to 1, log of a plus log of b. So log of a plus b by 2. So this is the log of limit x is equal to 0 of y is equal to 1 by 2 log of AB. Log of AB, or we can write log of AB just for half. Now convert taking into log of both sides. So take the log or compare them. Because logs are both sides. We are not supposed to convert into exponential form. Log here, take it into log both sides. So limit x is to 0 of y is equal to AB raised under root. Now similarly, you can solve this problem. Thank you very much.